Yeah, so my topic is harnessing customized built-in elements, empowering component-based software engineering and design systems with HTML5 web components. This topic is under the track of semantic web technology, and this is about me. Uh, and specifically speaking about the abstract or speaking about the scope of this research, there are several keywords and themes that this topic will cover. Specifically, before we dive deeper into what this research speaks to, I'll just break down what, and just cover in short these keywords. So web UI development, that's basically a process, and the science of software engineering, which basically pertains to building web applications. And specifically, when we say web UI, that pertains to not the entire application, but specifically the user interface and engineering the user interface, building it. Um, Now, HTML5 is one of the underlying technologies, HTML5, CSS3, and JavaScript. These are the underlying technologies which are used for building a web user interface. And specifically under HTML5, a newer API was released. It's called Web Components. Web components allow the flexibility for web developers to build their own components. These components are basically are independent and or could be derived from the native HTML5 components. And we'll dive into everything deeper. The third part is customized built-in elements. Out of the two categories of web components, basically, which you can build, the first one being anonymous, the second one is customized built-in elements. The topic of this research basically is focused very heavily on customized built-in elements and its application in component-based software engineering and design systems. So moving on, web development at this point is at the forefront of innovation and user-centric design in today's quickly expanding digital landscape. The advent of HTML5 customized built-in elements marks a watershed moment in the realm of web development, as per this research. These elements are customized built-in elements are a subset of web component standard and has the potential to transform software engineering, specifically its impact on design systems. Their ability for component based customized built-in elements to contain exact functionality, visual aesthetics, and interactive behaviors represents a new paradigm in web development, encouraging code modularity, reusability, and scalability. Now, diving deeper into the objectives and purpose of this research, this research investigates the importance of customized built-in elements under the HTML5 Web Components API. It emphasizes the importance in component-based software engineering and design systems. It also highlights the advantages that CBEs, in short for customized built-in elements, the advantages they offer, which are code modularity, reusability, and scalability, and how they promote the broad usage, to improve design coherence and improve user experience. So speaking in reference to the Web Components API, under Web Components API, there are 4 new features being supported. The first one being custom elements, the second one being shadow DOM, the third one being ES6 module imports, and then we have a fourth one too. Under them, speaking in reference under the the HTML5 web components, they feature a dynamic capability enabling developers to craft and establish their unique HTML elements, referred to as custom elements. These custom components provide a distinct and robust feature, allowing developers to encapsulate functionality, structure, and style similar to well-known HTML equivalents. So you can assume, so for example, these custom elements will allow you to create a class, and it allows encapsulation, meaning that it will have private variables, and which will be encapsulated and, will not pollute the global scope. And in terms of structure, you can reutilize HTML as a markup, and you can import CSS styles as well. Custom elements are at the heart of web component standard, and they serve as a gateway to increasing HTML's vocabulary. They, there are, we have an example which will highlight the power of HTML5 web components custom elements, which will allow to construct reusable encapsulated components with its own behavior and appearance. Now, specifically, just a second. Speaking in reference to customized built-in elements, before I go there, I can do a small demo. Just a second. Hopefully, you're able to see my screen, and this is what I'm showing is the official specification for the web component standard under HTML5. As I said, there are 4 features as part of the specification which were rolled out. The web component standard includes the custom element specification, the shadow DOM, the templates, and the ES6 module imports. And then we have the official guideline which speaks to the custom elements as well. This is the official guideline under W3C for the custom elements. You know, and so just an example, there are 2 types of custom elements. One of them is anonymous and the second being customized. This example speaks actually to an autonomous custom element. So you can create an autonomous version actually of a custom element or a component, and which uses a class, and it will extend from an HTML element. It can have its own lifecycle methods. It can have a constructor, and also it can, using encapsulation, it can have its own private variables. It also basically can do the rendering. This connected callback refers to a lifecycle method. And when we define it, we use the custom elements API to define and register this custom element. And one way of consuming it is either you can use JavaScript, and then you can add the element. Actually, you can inject the element in the body, or you can use a typical HTML markup. For example, if this is my checkbox is your custom element, you can use the same markup inside your HTML. Now, another example, the variant is offered under custom elements is customized built-in elements. Customized built-in elements differs from the anonymous in the sense that it will basically extend for an existing element instead of a generic HTML element. So you can basically extend a button, and you can decorate it by adding more functionality and styling. So in this case, this is an example of a plastic button extending an HTML button element, which has a constructor and has its own click event handler supported. And we register that custom elements using the custom elements API by obviously passing an identifier with which you will, an identifier or the tag name which you will use in the markup. You'll pass the class, and you will also extend the actual element that you are extending in the HTML specification. And here's another example. In the markup, you can basically use a button with an is attribute. This is attribute will pertain to the unique identifier for the customized built-in elements. And so clicking on that will trigger this event handler. Now we will also cover going back to uh, um, there's another example that I covered two of the examples. This is again covering an example on anonymous custom elements, wherein basically a word count component has been developed, which is extending an HTML paragraph element. This is an example of a customized, this is an example of which if it extends from a generic HTML element, it basically is an autonomous custom element. And then we also have lifecycle hooks. Uh, these lifecycle hooks are beneficial for triggering, or getting or basically running source code during the lifecycle of a component. For example, if a customized built-in element has been added to the page, the point at which it gets added will trigger this callback, the connected callback. And then while it is connected to the page, if any of its attribute is changed, it will trigger the attribute change callback. Now, if you want to observe or particular attributes to ensure, we can use the observability or the observer design pattern, and using that, we have attribute change callback, and we under that observe attributes is supported to keep an eye on when any of the attribute values being changed. And then when basically the page is removed, when the component is removed from the page, it will trigger the disconnected callback. We covered the demos just to give basically a deep dive into customized built-in elements. Now, certain advantages of the customized built-in elements as studied by this research. These custom elements allows developers to create and integrate their own HTML elements. These custom components like built-in HTML elements can extend these existing elements like div, paragraph, buttons, and can encapsulate functionality, structure, and styling. Um, and then this is a transformational approach to web development. CBEs also, the process simplify the process of user interface development. Uh, And this can be proven using some examples. We'll look at some of the examples. These are real world examples, which will, now here is one example of an expanding list web component built using customized built-in elements. This is a typical list. When clicked on it, it's going to expand, and it will have three levels of basically, so parent will have child, and we have three level of children available. And so the city of Leeds has basically these amenities: train station, town hall, Heathrow, and Yorkshire has three cities. Similarly, United States, it just shows an example, few of the states it has, and some of the cities beneath that. Now, this expanding list map component has been implemented using customized built-in elements. And here we see one example. We studied this example. So here's an example where for this expanding list, we have a class which extends an unordered list element. So essentially, by extending this unordered list element, we are deriving all the semantic structure and all the functionality and the accessibility support from unordered list, the UL element, as we say in HTML5 for this expanding list. And then we basically use a connected callback, which is a lifecycle element. And then we basically create a structure, based on the data that is passed. And we create a combination of unordered list and list elements beneath that. When clicked actually on them, any of these elements triggers actually these event handlers, which will toggle the styles into a block level element or may hide it. Uh, And then it will also insert and remove certain elements, actually DOM elements based on expand and collapse. Um, and this line pertains to how do you register that. Now, in terms of basically consuming it in the markup, as you can see, we use an unordered list element and use the is attribute. This is attribute and then registering it using JavaScript, using custom elements that define will ensure that it basically instantiates the class for expanding list, and it will basically use the functionality from that class. Another example we will look at is a word count component. In this word count component, we have this represents a typical example where you're typing a text in a text area, and it will give you a word count. So as I type further, it will count the words. And this implementation has been done using customized built-in elements. So we are using a paragraph tag, and we are using it as a customized built-in elements, and we have defined actually a class, and we are also using a shadow DOM to encapsulate the entire the scope or the DOM into this, so it does not pollute the global scope. Here's one example. Here's how the code looks like. The word count, in this case, it's a class which extends the HTML paragraph element. It has its constructor and no lifecycle methods used, but in this case, it does create a shadow DOM, and we attach a shadow DOM. As basically as you type more actually words into that, we have an interval which triggers, and then we count these words actually every interval of 200 millisecond, and then it basically updates the count over here. So that's another example. Going back to our presentation, applications of customized built-in elements. There are two applications that this research actually dives into more, apart from studying these elements and the API. The first being it's elevating, how does customized built-in elements, elevates component-based software engineering. Now, component-based software engineering is an architectural design practice or a paradigm by which, in a basically say a web application, you want to design a markup, or whether it could be a mobile application or a web application where you want to basically design the user interface. One approach to that is thinking of every elements of a user interface as a components. So you may think about pages, or you may think about screens, and you may think about layouts, but the most basic element on an interface would be a component. And so customized built-in elements elevates component-based software engineering, and several of its the principles underneath them. But as based on the research and the study we did, they support modularity, reusability, and maintainability. Modularity pertains to basically bundling these components, customized built-in elements, as part of a module. So and then these modules could be imported into a design system, and that design system could be imported into a web application. Reusability pertains to using a component multiple times while ensuring that the scope and in the encapsulation. It also supports encapsulation. So a particular state for a component is encapsulated within it. And maintainability ensures to the ability to basically easily debug or able to scale as well in future. and in also having a tab on its basically the usage of it in the code or and its API. In real world CBSE projects, customized built-in elements can be used to create complex data grids and interactive dashboards that are central to enterprise applications. Customized built-in elements also addresses these challenges by allowing reusability of existing components in the dashboards by migrating to customized built-in elements to provide a seamless interactive user experience for data manipulation. There are these two examples that has been studied in the research paper under this theme of CBSE. The second application is design systems empowered by customized built-in elements. Now, um, these these design systems, they basically enforce consistency, and customized built-in elements offers that. A good example is, say, an example of an e-commerce company that guarantees that buttons throughout its site, website app, and voice-activated assistants have a uniform look and feel by leveraging customized built-in elements. So in their experience, they could possibly have basically an enrollment experience or an enrollment wizard where a startup wants you to start, sign up for the service. They could have a sign up button. Now they could have several such basically experiences throughout their workflow where they want to have the customers basically, sign up either for the service or say particular for a newsletter. Now these sign up buttons could be consistent by using customized built-in elements. Also, alignment with brand identity is another application under design system. Using the customization options for the same sign-up button, the organization may align each button with its individual brand identity, resulting in a consistent and visual appealing user interface. Now, obviously they can be made consistent, but you can also basically, if a particular part of your subsite has a certain different unique brand identity, then this custom built and elements can also align to that. It does offer customization. Under the realm of web development, design systems have emerged as a fundamental framework. And so just basically some slides as we try to understand design. Yeah, so before we go there, we'll try to we will try to understand a design system again. These design systems are not merely a collection of UI components and style guides, but they also represent the cohesive set of principles, patterns, and practices that guide the design and development process. The importance of design systems lies in their ability to ensure consistency, improve efficiency, and foster collaboration among teams, ultimately leading to a more coherent user experience across various digital platforms. Yeah, here is an example of a design system. Basically, in terms of basically the structure, one way basically this underlying theory tries to explain design system is understanding that design systems have a certain foundation. These foundations are based on editorial guidelines, color schemes, grids, iconography, and image assets. These grids pertain to, when basically for a layout, these elements are basically laid out in terms of a grid based on rows and columns. And it will have basically a grid. It'll also have a color guidelines to support a brand identity. For example, say something like Facebook, you see the icon and the dominant colors across the interface are blue and white. Similarly, for a YouTube, it's basically red, white, and black. Now, these are part of the color schemes which will be, which will be consistent across the design system. Design systems also basically have UI patterns, and that the flow goes from the bottom to the top. Like it will have certain elements like text box, buttons, which are defined, which will be part of the component library. And this component library will be part of a module bundled in the module, and these module could be imported by templates to build layouts. Similarly, a design system will have design principles, implementation guidelines, and several do's and don'ts. One way to understand the design system is through like biology, like these bunch of atoms, they make up these modules and then organisms. And that's how basically an equivalent design system is, that's, this is basically a component library made up from components. And these templates, which is your product, could have these templates or layouts, which will be made up of these components, and these pages will be made up of these templates. Um, so the last part is considerations in implementing customized built-in elements. Um, to effectively utilize these HTML via customized built-in elements, our research has figured that one must have an in-depth knowledge of the technical intricacies, like understanding the API of customized building elements, involved, and then browser compatibility is also another concern. While most of the modern browsers, including Chrome, have embraced web component standard completely, including the customized built-in elements, discrepancies do remain in how different browsers handle custom elements, necessitating the use of polyfills for unsupported features. So for example, Safari actually does basically have certain issues with customized built-in elements, and for which there has been a polyfill that by a third-party developer, which has been developed to support certain deficiencies in supporting that feature. Now, developers must also test their custom elements across a spectrum of browsers to guarantee consistent behavior and appearance. Custom elements can introduce performance bottlenecks, particularly if they contain complex logic or are used extensively on a page. Um, so one must definitely basically evaluate performance as they basically scale the user interface using customized built-in elements. Accessibility is a non-negotiable aspect of web development. Designing CBEs should consider accessibility, making sure that they are functional and accessible for individuals and disabilities. Uh, Also, there are other considerations. State management within custom elements must be handled with care and to ensure tight coupling the elements to a specific state. Security consideration are paramount, as custom elements can be susceptible to the same range of vulnerabilities as any web technology. Interoperability. Uh, the custom elements should be implemented so that they are designed to work with different contexts, which may involve managing events and data flow between components. In terms of this research, also basically studied the future of customized built-in elements. The horizon for customized built-in elements is expansive and promising, with the potential to revolutionize web development in profound ways. Within the development of Internet of Things, these components act as the medium for intricate interactions between devices, facilitating user-friendly control interfaces and enhanced visualization of data. Also, performance is basically one of the areas actually which can be researched or in future could be studied in further. As basically pointed out in the previous section, performance is one of the considerations. There could be a study, what is the performance on the page when you are basically utilizing 10 customized built-in elements versus 100 or versus 1,000. And that can be studied against custom element, anonymous custom elements, and that could be studied against native custom elements. Some other support could also, another area of research could be in future could be how are these customized built-in elements supported by other web-based frameworks like Angular, by React, by Vue.js, and whether they support all the features of CBEs apart from the support that the API, the JS library adds. Also, the last and not the least, the integration with progressive web apps. Um, Progressive web apps basically signify a very good paradigm for creating web applications, which also basically can be used as a desktop application or could be used as a mobile application. And customized built-in elements could play a significant role in the development of progressive web apps. Here's one graphic or a poster which basically explains progressive web apps and why customized built-in elements could be very immensely helpful. Progressive web app presents a paradigm where basically the web application can load instantly on any device or a browser. They respond quickly to user interactions and queries. They are mobile friendly. Instead of building a native application, an iOS application, and launching it in the App Store, or building and having a separate Android application source code and releasing it in the Google Play Store, you could have just one hybrid web application, one web application, which could be a progressive web application, and you could basically use that sort of like a native experience across iOS and Android. PWAs also provide a seamless user experience with low latencies. It allows you to subscribe to push notifications. And with that kind of advantages, customized built-in elements could be immensely helpful with with the advantages in component-based software engineering and its application and design systems. There are several challenges and considerations basically that this research studied when consuming customized built-in elements. These elements, customized built-in elements, it's important to ensure that they adhere to web content accessibility guidelines. These guidelines speak to the varied levels of support of web accessibility 2.0, 2.1, and recently released 2.2 to ensure that they're accessible and user-friendly for individuals with disabilities. CBEs that handle data must be designed to prevent vulnerabilities such as cross-site scripting and ensure data privacy. Tooling and developer experience, advancing the design of more advanced tools will be crucial for facilitating the creation and upkeep and debugging CBEs. While creation is basically guided by the API, and we basically looked at several demos, and we also looked at several examples how to do it. But in production environments, it's important that how would you be able to debug a defect in your application? So there are limited tools available. There could perhaps be more tools in future. Standardization and community engagement, the evolution of web standards will continue to shape the future of CBEs. And in future, basically, currently, there are limited basically resources and like these support groups. And so in conclusion, we studied this research studies the HTML5 customized built-in elements and in depth, and it represents a pivotal advancement in the realm of web development. This approach significantly enhances, CBEs also support modularity, reusability, and scalability within design systems and hence within web applications, marking a new era in web development. This transformative technology has the potential to reshape both component-based software engineering and design systems, ensuring that software development becomes more efficient and design systems visually cohesive. Any questions?